let's move straight to alkanes. Because we don't have time. So quickly. Okay. Tell those people over there that we're about to start. All right. Now, in hydrocarbons, we have the aliphatic hydrocarbons, we have the aromatic hydrocarbons. Under the aliphatic hydrocarbons, we have the acyclic, we also have the cyclic. The acyclic are the ones that do not exist as what? As rings. They exist as open chain. And then we have the cyclic, the ones that exist as closed shape, that's as rings. For example, we have cyclopropane. This exists as a ring. This is a cyclic compound. But we have a cyclic compound. For example, propane. This exists as a chain. It's open, it's not closed. So in hydrocarbon, we have compounds that are cyclic, just like this one, and then cyclic, just like this one. And the cyclic and the acyclic, they have further division. But under the acyclic, we have saturated compounds, and we have what? Unsaturated. Now under the saturated, we have the word alkane, while the unsaturated ones are the alkene and the word alkyne. So the first hydrocarbon we are going to consider is the word, the alkane. That's the first hydrocarbon we are going to consider, the alkane. Alkane. So alkanes are saturated, acyclic, aliphatic word, hydrocarbon. They are saturated, they are also what? Acyclic, and they are what? Aliphatic. So alkanes are saturated, acyclic, and aliphatic hydrocarbon. They are saturated because they contain only single bond. Between carbon wall atoms. So alkanes are saturated, and why are they saturated? We have only single bond between the wall, the carbon wall atom. So between the carbon atoms in what? In alkane, the bond we have are all what? Single wall bond. The bonds we have there are single bonds only. So once you see an alkane, the bond between the carbon atoms in alkane must be what? Single bond. So we can have this single bond, single bond, single bond. That's why they are what? Saturated. They are saturated because the bond between the carbon atoms are what? Single bond. We know that there are hydrocarbons in this form where we have at least one double bond. This one is not what? Saturated. The same way we can have a hydrocarbon containing at least one what? Triple bond. This one is not also what? Saturated. This is unsaturated. This is unsaturated. But when you have a hydrocarbon, and that hydrocarbon is acyclic, and also aliphatic. And that hydrocarbon contains only single bonds between the carbon atoms. That hydrocarbon is what? Alkane. So in alkane, you cannot see double bond or triple bond between carbon atoms. You cannot. Huh? Not all alkanes are gas in room temperature. We have some that are gases at room temperature. We have some that are liquid at room temperature. For example, methane is a gas at room temperature. Hexane is a liquid at what? At room temperature. You see that? So their physical state changes with the number of what? Carbon atoms. As the number of carbon atoms increases, they move away from being gases to what? Liquid, and eventually to solid. The alkanes with carbon atom of about 17 will be what? A solid. Will be a solid. So they can exist as gases or liquids and the what? Solids at room temperature, depending on the number of carbon atoms present in that in that alkane. Okay. So the general formula of alkane, is CnH2n plus 2, where N is the number of carbon atoms, with integral values of N equals 1, 2, 3, 4, 5, 6, and so on. So the N in the alkane, in this general formula of alkane, is actually number of what? Carbon, not number of what? Hydrogen, but number of what? Carbon. The number of carbon. So what is the number of hydrogen in alkane? What's the number of hydrogen in alkane? 2n plus what? 2. That's the number of hydrogen. Look at the number of hydrogen. All of this stands for number of what? Hydrogen now. It's number of hydrogen. That's it now. This n is number of what? Carbon. So 2n plus 2 will give us number of what? Hydrogen. Number of hydrogen. You see, that's one of the questions they should be asking students. What's the number of hydrogen in alkane? And someone will say, they did not give us the formula of alkane. They did not give us the molecular formula of alkane. How are they asking us to find the number of hydrogen in alkane? These people are wicked. There's nothing you will tell me. They are very wicked people. And maybe someone will now ask another question. An alkane has 6 carbon. An alkane has 6 carbon, right? How many hydrogen is present in the alkane? That's 14, right? Because if you know the number of hydrogen, this C stands for number of carbon, right? Yes. That's number of carbon. And then in an alkane, the number of hydrogen is what? 2n plus 2. So if n is 6, it's 2 times 6 plus 2. That will give me 12 plus 2. And that's what? 14. Or if you have mastered the whole, right? If you have mastered the first 10 alkane, you can easily know that hexane has what? 14 what? Has 14 hydrogen. Just double the alkane, add 2 to it. Double the, number of carbon, add what? 2 to it. Double the number of carbon, add 2 to it. You will get your what? You will get the number of hydrogen. Okay? So N is the number of what? Number of carbon. So in alkane now, if we have number of carbon, we have number of carbon. And then from there you can get the formula of alkane. Let me reduce this number of carbon. number of carbon, and then you can have the formula of the alkane. Then here you can have the name of the alkane. Remember that if this is number of carbon, that means it is what? N, right? Yes. So when N is 1, if you use your general formula, you can actually obtain the what? The members of the alkane family or the homologous series, the alkane homologous series. So if N is 1, remember we have CN H2N plus what? Plus 2 as the general formula, right? Yes. So if N is 1, you put 1 here, right? Yes. And then take 1 here also. Okay. So we are going to have just 1 carbon, right? Yes. 1 times this will give you what? 2. 2 plus 2 is what? 4. So we have CH4. When N is 2 now, we repeat the same process. N is now 2, so number of carbon is what? 2. And then put 2 here. 2 times this is what? 4 plus 2 will give me what? 6. So I have C2H6. If it is 3, I'm going to have C3. 3 times this is what? 6. 6 plus 2 is what? 8. So we have that. So we have the 4th one. We're going to have C4. Then 4 times this is what? 8 plus this is 10, right? So we have H10. Then we have C what now? 5. H what? That would be 12, right? Just double the number of carbon, add what? Add 2 to it. So when it is 6 now, we are going to have what? C6H what? 14, right? 7 now, we are going to have C7H what? 16. And when it is 8, C8H18. And C9 now, when it's 9, we have C9H what? 20. And when we have 10 carbon, C10H22. It continues, right? Then, what's the name? 1 carbon, we have this, a sort of prefix. 1 carbon is met, right? 2 carbon, what? X. Now, the root there is ANE from alkane, right? Alkane. So, we have a prefix before this ANE word, E, right? The prefixes are all about number of what? Carbon. So, met, then before ANE, telling us alkane with 1 word, carbon. That's why we have what? Methane here, right? And this one now is what? Ethane. This one is propane. This one is butane. Then you now start remembering the rest. This one is plantain. Sorry, pentane. That is pentane, right? Not plantain. Okay, this one is what? Hexane. Then this one is what? Hexane. Just like you have in your polygon. This one is what? Octane. This is what? Nonane. And this is what? Decay. And so on. These first 10 members, you must know about them. You must know their molecular formula and how you can also draw their word, their structures. So that's the first 10 member of the alkane family from 1 to what? To 10. 1 to 10. 10 members. So alkanes are saturated, and we have explained why they are saturated. They contain only single bond between the carbon atoms. So if you see any alkane that has double bond between the carbon atom, that alkane is committing sin. It's committing chemical iniquity. It is committing chemistry iniquity. So we cannot have such alkane. It's not possible. We cannot have such alkane. Okay. Now before we move to the naming of alkane, I'll just quickly do 2 things. Before we move to the naming of alkane, one of the things we are going to do is to just show a little representation on how we can draw the structure of what? Of an alkane, right? How we can draw an alkane. and then we talk about alkyl groups. When we are looking at the basic terms associated with what? With organic chemistry, we mention substituent groups. We mention substituent groups. And we say that substituent groups are groups that are attached to the parent chain or the main chain of what? Of any organic compound, not necessarily alkane, all organic compounds. Any group that is attached, that means that group is not part of the parent chain, but it is what? Attached to it, right? That particular group is called a substituent what? A substituent group. That's the name of that particular group, a substituent group. Any group that is attached is called substituent what? A substituent group. And we're going to look at one of the substituent groups. That's what we call an alkyl group. We're going to see an alkyl group. But before then, if one wants to draw the structure, of any of these alkane, right? Let me take the one that has much carbon. Let me take C7H1, 16, that's heptane now. The first thing you need to do is to draw the carbon what? Atoms, right? You draw the carbon atom. So I'm going to have C7 carbon, that's what we have. Is it complete now? Yes, it's complete now, 7 carbon. Now, we have already said that in organic compound, carbon must have how many bonds? 4 bonds, right? So it means that this carbon is still lacking how many bonds? 3. This one, how many? 2 bonds are missing. Here, this one 2. This one 2. The same thing applicable here. The same thing applicable here. And this one, how many? 3. Now you notice, since it's a hydrocarbon, the remaining elements that will complete this bond are what? Hydrogen. All the bonds will be completed by hydrogen. So we have hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here. So that's the what? That is heptane now, right? That's heptane. And if you check the carbon here will be what? 7. And if you count the what? You count the hydrogen here, it will be what? 16. Already we have 7 here, 7 here, 14, 15, and the what? 16. When we looked at structural formula, we talked about expanded structure, and we also talked about the what? Condensed formula. We can condense this, right? We can condense it to give us CH3 for this, right? 1, 2, 3, CH3. This is bonded to what? CH2. Bonded to another CH2, to CH2, 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 and CH3. So these 3 hydrogen here, these 2 hydrogen on this carbon, these 2 on this carbon, and so on. Now we can still condense further, right? We explained that 1, 2, 3, 4, 5, the same thing. So I can just write it like this. CH2 times 5 into 5 times, right? So this is still the formula of hexane. So sorry, heptane, this heptane, this heptane, this heptane. Now in my class, I prefer to use this condensed formula, this particular one. That's the one I use often. WAEC, JAMB, NECO, and other exam bodies can still use this. They also use this. They can also use this. But the common ones are this and the one, this. At this level, we will not be talking about skeletal word formula. I don't want anybody to start shouting. Or maybe we'll start drawing the skeletal formula and some people will become skeleton. Now that your body is covered with flesh, maybe if we start drawing the skeletal formula, the flesh will start disappearing. And this your flesh that have been hiding your tiny bones. You start seeing your tiny bones. So we are not going to look into the skeletal formula. We'll just be looking at the condensed formula and this expanded structure. Okay, so that's how you can actually draw the word, the structure of what? Of alkane. Always begin by just drawing the word, the carbon, right? And then before you now place the hydrogen atom. Before you place the hydrogen atom. Okay. We're going to look at alkyl group because it will not be possible for us to do what? To look at nomenclature of alkanes if we don't know about what? Alkyl groups. We cannot look at nomenclature of alkanes until we have looked at what? Alkyl groups. And if you master nomenclature of alkanes, it makes life easy for all of us. It makes life easy for all of us because in the subsequent nomenclature that you are going to look at of other homologous series, you can build up from there, from that of alkane. Because there are rules that we are going to write down concerning the nomenclature of alkane that will be very, very useful in the nomenclature of other homologous series. So let's talk about alkyl group. Can I clean this? Or this one? Which one? Both of them? Yeah. Anyone? Okay, let me clean this one now. Okay. Some people are still shouting no. And they are the same people that want us to finish the class on time. And they are shouting no. Until I keep people here till 7 in the night. Don't shout, I'm not keeping anyone. So let's talk about alkyl groups. Alkyl groups are formed when a hydrogen atom is removed from an alkane. When you remove a hydrogen atom, just one hydrogen atom from an alkane, you will form what? Alkyl group. The general formula of alkyl group is CnH2n plus 1, where N is the number of carbon. With integral values of N equals 1, 2, 3, and so on. So the general formula now is what? CnH2n plus what? 1. That's alkyl group. Remember, we just said that an alkyl group is a group formed when you remove what? A hydrogen atom. When you remove a hydrogen atom, just one hydrogen atom, from what? An alkane, you form what? Alkyl group. Now, if originally the number of hydrogen atoms in what? In alkane is like this, right? 2n plus 1. If you remove 1, minus 1 will give you 2n plus 1, because 2 minus 1 is what? 1. So the general formula of alkyl group now is CnH2n plus 1. Wow. That's the general formula of alkyl group. CnH2n plus 1. Now the symbol of alkyl group is what? R. In organic chemistry, R represents what? Alkyl group, right? In organic chemistry, R represents what? Alkyl group. So anytime you see R in organic chemistry, we are dealing with what? Alkyl group. So if you have something like this, ROH, it means that this alkanol, right? This alkanol, that means this R is alkyl group. And that's why you see methanol, for example. The whole of this is what? Alkyl group. Ethanol. The whole of this is what? Alkyl group. The old name of alkanol is alkyl alcohol or alkyl hydroxide. Alkyl alcohol. Alkyl alcohol. Because, for example, you have CH3OH. This represents alcohol, right? So methyl alcohol, methyl alcohol, ethyl alcohol. So arrow, what I'm trying to say is that arrow represents your what? Alkyl group. Because you're going to meet R often in organic chemistry. If you go to carboxylic acid, you still see this. You go to ester. This one is carboxylic acid, RuCOOH. Then ester, RuCOO. We may put prime. This arrow prime is still an alkyl group. Why we added prime here in that case is to show that maybe the alkyl group you have here and the one you have here are not what? The same. You may have methyl here and you have what? Ethyl here. So if you leave it as arrow and arrow, there will be confusion. So just to distinguish the two alkyl groups, you put prime there. Some textbooks may use arrow 1 and arrow 2. But generally, we know that arrow represents what? Alkyl group. Even in our mind, you say arrow NOH2, depending on whether it's primary, secondary, or tertiary amine. So we're going to see all of that later. So the symbol of alkyl group is what? R. So in organic chemistry, wherever you see arrow, arrow is talking about what? Alkyl group. It's talking about alkyl group. To name alkyl group, we remove the ANOE in the corresponding word, alkane, and replace it with Y word, L. So to name alkyl groups, the ANOE in the corresponding alkane is replaced by YL. So we use YL to replace it. We use YL to replace it. The ANOE in the corresponding alkane will be replaced by what? By YL. Use YL to replace it. That means where you have methane now, where you have methane, you will now have methyl. Methane. If it loses one hydrogen, you also lose ANOE and move from what? Methane to what? Methyl, like this. So if methane has formula CH4, when you remove one hydrogen, it will become what? CH3. You see, I drew a line here showing that this bond must complete to 4, right?
Yes.
This bond, so that I have 1, 2, 3 plus this one 4. I cannot just write this like this. It's wrong. So I have to indicate the bond from where we remove the what? The hydrogen. So this is methyl. So let me just drop a simple table of maybe three common alkyl group at this level. We have so many of them, but let's look at this. Let's look at this. We have alkyl group. Alkyl group. Okay. Alkyl group, and then the structure, the formula. Let's use formula. Whether structural formula or molecular formula. Now, the first one is methyl, formed from what? Methane, right? The formula is CH3. If I expand it, I can still write it like this. H to C to H to what? H. While we have this one other bond that will be attached to what? A parent chain. So this is methane. This is also what? Methane. If you expand it, this is methane. Okay. Now we have another one, which is the word ectyl. Ectyl is like this, which I can expand. If I expand it, I can write it as CH2 to what? CH3. Right? So if it is not in this form, it can be in this form. Remember, you can still turn this, forming the mirror image of this. You have what? CH3 to what? CH2. Do you agree? I hope you know this is this now.
Yes.
All I did was just to... Okay. Okay. So that's ectyl. That's ectyl. Then we have propyl. I'm going to draw propyl in two forms. One is propyl. The other one is isopropyl that we call methyl ethyl. Methyl ethyl. So the A is what? Propyl. Propyl is C3H7 or CH3 to CH2 to CH2. Right? That's propyl. With this bond, that's propyl. Remember, you can still reverse it and start with CH2, CH2, right? That is CH2 to what? CH2 to CH3. So this is propyl, this is propyl, this is propyl. But we have isopropyl that we call what? We call methyl ethyl. Methyl ethyl, that's the B here. The structure of methyl ethyl, is CH3 to CH to CH3. That's methyl ethyl. Methyl ethyl. An isomer of the what? Of the propyl. An isomer of the propyl. Here, it is the bond that can be here. I can still put it up here, right? I hope you know. Butyl, C4H9. And from butyl, we can have isobutyl, C4H9. And from butyl, we can have isobutyl. For example, methyl. Now that we have looked at